Welcome to this lecture. In the last lecture, we were discussing testing branches, and we said that the simple branch decision coverage testing is not really a good enough testing. Bugs can remain if the branch condition contains multiple sub expressions. And then we looked at the basic condition coverage testing, and then we said that even though it overcomes some shortcomings of the branch coverage testing, but it is not really a stronger testing than branch coverage, and therefore we considered the condition decision coverage testing, where the basic condition testing is achieved and at the same time branch coverage is achieved. But then we are trying to see which is the strongest branch testing strategy, and we said multiple condition coverage testing, where each of the sub expression is given all possible combinations of truth values, but then the number of test cases became exponential. Let us continue from that point. Let us consider a Boolean expression having n sub expressions or components. The multiple condition coverage MCC or the multiple condition coverage will require 2 to the power n test cases, and that is the reason why MCC testing is not considered practical if the number of sub expressions are more. Even if we have 5 clauses here, this example expression, just 5 clauses, and to test for multiple condition coverage we need 2 to the power 5 test cases, and that is 32. But then we will see that short circuit evaluation reduces the number of test cases to a more manageable level. The short circuit evaluation means that compiler, while evaluating, it infers whether it needs to evaluate further. For example, let us say A is true, and let us say C is true, then the others the compiler does not really bother, because they will have no effect. If A is true, then this expression is true, and if C is true, then this is true, and if E is true, then turns out to be true, D does not matter. So, B and C, whether it is true and false, it does not matter. So, we can just consider one of that, and therefore, the number of test cases reduces by 1. But what about if let us say A is true and C is false, then this becomes false irrespective of the value of the B, and let us say D is false. So, that means this is false, and therefore, E does not matter. So, we can just consider one of the 2 possible test cases, and therefore, the number of test cases may not be 32 due to short circuit evaluation technique. used by the compilers, because they want to execute fast, and they see that if the truth value can be inferred as they evaluate, then they do not evaluate the other ones. So, even though we are saying that 32 test cases are needed, but then depending on the compiler, the short circuiting approach that it takes, we might need much less than 2 to the power n to achieve the multiple condition coverage testing. So, based on our discussion so far, we can say that the statement coverage is the weakest testing, and so is the basic condition coverage testing, but then they are not comparable, because basic condition testing does not ensure statement coverage testing and vice versa, but then the branch coverage testing or the decision testing is stronger than the statement coverage testing, and the condition decision coverage testing is stronger than both basic condition testing and the decision testing, and the multiple condition testing is the strongest of all these, but the only problem is that it is not practical when the number of sub expressions is large. We had seen that the short circuit evaluation approach used by compilers often reduces the number of test cases to achieve multiple condition coverage. Also, we must remember that certain coverage may not be achievable. Let us say we have an expression like character is A or character is E. Here we cannot achieve the basic condition coverage also, because we cannot have we can achieve basic condition coverage, because we can have this as true and this as false and this as true and this as false. We can achieve basic condition coverage testing, we can achieve decision coverage testing, but can we achieve condition decision coverage testing? That also we can achieve, but what about multiple condition coverage testing? Can we achieve both of these true at the same time? No, because the character cannot be same at the same time A and E. So, multiple condition coverage testing we cannot achieve for this, and that we must keep in mind, that we cannot achieve multiple condition coverage testing even though we deploy thousands of test cases. We cannot achieve multiple condition coverage even for simple expressions. Let us look at a few more short circuit evaluations. In this expression, there is a AND here, and therefore, wherever there is a AND, if one of the sub expression evaluates to false, then the clause has to the decision has to evaluate to false irrespective of the other clauses. The compilers take advantage of this, and as soon as they find a false here in this kind of expression, they will not evaluate the others, they become do not cares, and the outcome will be false. Whenever there is a OR condition, whenever there is any sub expression evaluates to true, then the others become do not care and the decision evaluates to true. The decision will become true even if one of that is true, and if the compiler deploys short circuit evaluation, it can save lot of time and skip evaluation of sub expressions. Now, let us look at a test strategy which is a strong testing for decisions. It overcomes the problem of the multiple condition coverage testing, which required a large number of test cases. When we had a decision involving let us say 10 sub expressions, for multiple condition coverage might need 2 to the power 10 test cases, which is about 1000 test case. But if we use the MCDC testing, that is multiple condition and decision coverage, then we might need let us say 7 or 8 test cases, but this 7 or 8 test cases we can see experimentally that it is almost as good as the multiple condition coverage testing, and undoubtedly the multiple condition decision coverage or the MCDC coverage testing is a very powerful strategy. With very small number of test cases, it can achieve a thorough testing of the branches, and therefore, it is a very popular technique and incorporated into many testing standards. Now, let us look at the MCDC testing. Here we need to test all possible outcomes for each of the conditions. These are the basic conditions, but then we require that they independently affect the outcome of the entire decision. What it means is that we not only require that each of the sub expression achieves true and false values, but also while the rest of the expression is held at some truth value, if we make this true to false, then the decision should also change. The decision outcome will become false if we make this as the false, and if we make this as the true, then the decision outcome should become true. Our test cases should be able to achieve that, and then we will say that this satisfies MCDC coverage criterion. So, here the MCDC coverage requires that for every basic condition in a complex conditional statement, the compound condition evaluates to true and false as the basic conditions are given true and false values. Let us explore further about this test technique. So far, we looked at the condition decision coverage testing. It achieves both condition coverage and decision coverage. The multiple condition coverage testing, which required exponential number of test cases, but it was a strong strategy. And now, we are going to discuss about the MCDC testing, where the bug detection effectiveness is very similar to the MCC, comparable to the MCC, but the number of test cases is linear in the number of basic conditions. If we can draw the subsumption hierarchy, we can see here that the MCDC testing is requires small number of test cases. It is stronger than condition decision coverage testing, but of course, it is weaker than the MCC, multiple condition coverage testing, but multiple condition coverage testing requires huge number of test cases, but MCDC testing achieves testing which is very close to the MCC testing. So, that is the reason why MCDC testing is an important test strategy used extensively during testing. Now, let us try to understand what is MCDC and how to design the MCDC test cases. As we have been already using the terms condition and decision, the condition is the atomic condition in an expression or is a sub expression. The decision is the outcome of a decision statement and controls the program flow. Already seen what are the basic conditions and what is the decision. The main idea in the MCDC testing is that given an expression having multiple atomic expressions or conditions, each condition must be shown to independently affect the decision. That is, if we have a expression like a greater than b, a greater than 10 or c equal to 5 and d greater than 50. Let us say this is our expression or the decision statement. Now, for achieving the MCDC, we will hold it with some value, let us say c equal to 5 and d is equal to let us say 60, and then as we make a greater than 10 that is true, then the outcome should be true, and if we make this as false, the outcome will become false. And similarly, if we hold this and this to some values, some truth outcomes, let us say this is true and this is let us say true, then if we make this as true and false, the decision output, the decision outcome should also become true and false. Similarly, for this clause, the third clause, if we the second clause, if we hold these two in some true and false values, let us say this is true and this is true, and if we toggle this this is false and this is true, and as we toggle this second sub expression to true and false, then the outcome will toggle to true and false. Let us see, does it really do? We have held this first sub expression to false, the last sub expression to true. Now, if we make the second sub expression to let us say true, then this evaluates to true and then this is also true. So, the outcome will be true, but what if we make this as false? So, let us say now the try with false here. So, this is false already, this is false. So, this becomes false and this is true, and therefore, the outcome will be false. So, we can say that if we hold the first sub expression to false, the second sub expression the last sub expression to true, then if we toggle the second sub expression to true and false, the decision outcome also toggles to true and false. We need to do that for every sub expression, that it will independently affect the outcome of the decision. So, that is the main idea here in the MCDC testing. If we formally write down what we need during MCDC testing, the first requirement is that the decision should have got true and false value by the test cases. Every condition or the sub expression must have got true and false values during the testing, and also each sub expression should independently determine the outcome of the decision. So, these are the three requirements. Let us try to understand with some examples. Let us look at this expression a greater than 10 and b less than 50 and c equal to 0, then something, and we want to test it such that the test cases will achieve MCDC coverage. So, we need to assign the first sub expression true and false values such that the decision will become true and false. So, the first thing is that the decision as a whole should become true and false, and if we assign true and false to this, that is A is 20 which is true and A is 5 false, then the outcome should also become true and false. So, for what values of these two, if we hold them constant, will this toggle the output as it becomes true and false. So, if we have this true and this true, that is b is 20 and c equal to 0, then this sub expression becomes true. And see here there is a AND here. So, if this is true, then the outcome, the decision becomes true. If this is false, then this is true and the outcome becomes false. So, as the first expression becomes true and false, if we hold these true to true and true, then the outcome, the decision outcome toggles. Similarly, we need to do for the other two sub expressions. So, for this, as it becomes true and false, we need to hold these two such that the outcome becomes true and false, and also for the last sub expression. So, that is the requirement for MCDC. And what are the values which will achieve MCDC coverage for this? One is that we hold this to true and this to false, if this is OR, and then as it toggles between true and false, this will, the decision will toggle between true and false. And for this situation, for the second sub expression, if we hold this to true and this to false, then the outcome, decision outcome will toggle between true and false. Similarly, if we hold the first one to true and the second one to false, then the third sub expression, as it becomes true and false, the decision will toggle between true and false. But then the question remains that given a complex expression which is having a large number of sub expressions or conditions, how do we design the test cases such that MCDC coverage will be achieved? Let us first look at an example, slightly larger example, so that we can get the idea about how to achieve MCDC coverage. we first develop the truth table and then we check that if the first one is true, then how can the output, okay, this is true, and for this one the outcome is true. This one first sub expression is true and the outcome is true, and we scan here and see that for same values of the other sub expressions, here as it toggles between true and false, the outcome becomes false. So, these two test cases together will achieve the independent evaluation of the first condition. What about the second condition? The second condition, we scan through the truth table and find that when this is true and the others are true, false, true, this is true, and when this is false, then the others are held at true, false, true, and we get false. So, these two together achieve the independent evaluation of the second clause. The third clause is when this is true and the others are false, true, and true, and this is false, others are false, true, and true, then the outcome toggles. So, we also need this, and so on. So, for every condition, we look at the truth table and then we examine that when does the output toggle, the decision outcome toggle, when the specific condition toggles. So, this is the main idea behind MCDC. We are almost at the end of this lecture. We will stop here and continue in the next lecture. Thank you.